thank you, Chancellor Weir. I recently had to watch all 13 episodes of Cosmos. We're putting together the videotape version of that. I never said it. I said there's hundreds of billions of stars in the Milky Way galaxy. I said there's billions of trillions of stars in the universe. I never said billions and billions. Johnny Carson said it, but not me. It's too imprecise, billions and billions. It's very vague. It's sort of... I'm very happy to be here with you, celebrating this rite of passage, and I want to wish you all the very best of luck at a key and critical time in human history. For myself, when I graduated college, I never had any intention of being involved in public or political issues. I just wanted to explore the planets, see what they were like. You'd think that there was nothing so remote from earthly concerns as the planets and the stars. And it's been my good fortune, as Chancellor Weir briefly mentioned, to have participated in a stunning set of spacecraft exploratory ventures which have taken us, our robots, and by extension ourselves, to explore the entire solar system. Last August, the Voyager 2 spacecraft passed through the Neptune system, and except for the single small planet Pluto, the human species has, in the last 30 years, explored all the planets of the solar system. There's only one time when that is accomplished, and we are fortunate enough to be alive in that time. Among my interests in spacecraft exploration of the planets is the very natural interest in the possibility of life elsewhere. We have explored dozens of worlds, if you count the moons of the planets. We have found much that is instructive, an enormous amount that was unexpected. We have seen glorious landscapes, but we do not have the faintest hint of the presence of life elsewhere. There are the stirrings and intimations in many worlds where organic matter is assembling itself, but not a hint of life. And so, after that experience, it's very natural to look with new eyes at our own planet, the Earth, and to recognize how extraordinary it is, a world graced by life. And the conclusion seems to be that you can have many worlds, dozens of worlds, and life on only one of them. It underscores the scarcity, the preciousness of life. It seems to call to us to work to preserve and cherish this remarkable phenomenon that we are so deeply part of. And another activity in space, for me, underscored this lesson, and that was the succession of pictures, but especially the earliest Apollo pictures of the whole Earth. You take a look at those pictures, and you see this exquisite blue and white world set like a jewel against the velvet blackness of space. And the thought that arises unbidden, I think, in every astronaut who has seen it, and every one of us who has seen the pictures, is again about the delicacy, the fragility, the vulnerability of the Earth. And what strikes me especially is if you look closely, there's a thin blue aura that surrounds the Earth on its daylit hemisphere, and that's just the atmosphere. Its thinness is what is so striking. The thickness of the atmosphere compared to the size of the Earth is roughly the same as the thickness of the coat of shellac compared to the size of a library globe of the Earth. There isn't much air. Now, when our numbers were few and our technology feeble, it was impossible to imagine that we humans could affect the life-sustaining environment of our planet. But now that our numbers are enormous and our technology formidable, even awesome, the situation is different. And it is now clear that we are able, on purpose and even inadvertently, accidentally, to make disastrous changes in the life support system of our planet. For me, I've been led to 3 of these vulnerabilities precisely by examining other worlds. It turns out, it seems to me, that you can learn a great deal about your own world by studying others. So I was led to the discovery that my colleagues and I made of nuclear winter by studying dust storms on Mars. That was the first step in the long sequence of work that led us to discover this planet-wide climatic catastrophe that now is widely agreed as a possible consequence of a global nuclear war. Also on Mars, there is no ozone, or very little, and the ultraviolet light from the sun can strike the surface of that planet unimpeded. And when we landed there in 1976 with the 2 Viking landers, we found a strangely antiseptic surface. Not only no sign of microorganisms, no sign of bigger organisms, I mean, not a blade of grass, not a microbe, but not even an organic molecule. And our understanding of that is that the ultraviolet light from the sun has sterilized the surface of Mars. And Venus is a world with a massive greenhouse effect produced largely by carbon dioxide and water vapor, so hot that the surface is at 900 Fahrenheit, hotter than the hottest household oven, hot enough to melt tin or lead. Now, I'm not saying that there used to be a species of Venusians who drove fuel-inefficient automobiles. That's not my argument. But I say that each of these 3 serious, real, or potential assaults on the Earth's atmosphere have analogs, have warning signs on other planets. There is a delicate balance of invisible gases on which we depend. And it is our job to make sure that that subtle, delicate, life-supporting environment is maintained. And incidentally, since these are invisible gases, since these potential disasters are in a very different category from an invader from a foreign country, we must be able to understand science in order to assess and deal with these dangers. It's a very different kind of discipline that's required to face the new category of dangers. There are a set of changes that I think are clearly needed to deal with these dangers. On the nuclear war issue, it is absurd, it is obscene to have a world with nearly 60,000 nuclear weapons in them, almost all of which are more powerful than the bombs that destroyed Hiroshima and Nagasaki, when less than 1% of that number might bring on nuclear winter. If you are interested in the idea of deterrence, you can maintain that deterrence with a tiny fraction of the existing arsenals. Ozone depletion, we know exactly what the principal agent is. It's a category of molecules called CFCs. The DuPont brand name is freons. There is an international protocol to cut them in half by the turn of the century. That's not nearly good enough. We must simply remove those molecules from the face of the earth. And for greenhouse warming, there is a set of considerably more difficult steps that are required, including much greater efficiency in the use of fossil fuels, a vigorous research and development effort for alternatives to fossil fuels, especially solar power, and massive reforestation, since forests take carbon dioxide out of the atmosphere, growing forests do. Instead, our species is destroying an acre of forest every second on the earth. Just think about that for a minute. And then finally, none of these steps will be useful, no matter how heroic they are, if we don't do something about the enormous growth in our numbers. The world population crisis is key to many other crises, and there is no likely solution to that without raising the standard of living of the poorest people on the planet. It seems to me, if we're concerned about preserving the environment on which we depend, there is a clear and unfortunately urgent set of steps that have to be taken. Now, molecules don't have passports. Molecules are terrifically dumb. They do not understand the important idea of national boundaries and national sovereignty. You put CFCs or carbon dioxide up above one country, and the circulation of the Earth's atmosphere carries it all over the world. This new category of global environmental problem requires a trans-ideological, a trans-national, let's think about the unification of the world. We humans started out in East Africa 1 million years ago or so. We were one people. We spread all over the planet. We differentiated, especially culturally. And now, through technological advances, especially in transportation and communications, we are reacquainting ourselves with each other. The walls are falling down. There is a new partial union of the nations of Europe coming about in 2 years. Democracy, civil liberties, freedom of speech are suddenly fashionable. And I think this is just in time. These are essential tools for understanding the new world we are entering and helping us to figure out how to solve these serious problems. So I would like to urge you, I know this is a day in which everybody is telling you what you have to do, and you certainly might be tempted to listen politely and pay no attention. I urge you not to sit this one out. We cannot leave the solution of these problems to politicians and bureaucrats. We have had a lot of experience with them. The people have to take charge. For those of you who are, in the most serious sense, coming of age in this time, It seems to me there is a profound obligation to play a role in determining and safeguarding the human future. Your lever arm is long. Your potential influence is great because this is such a critical time in human history. You have an opportunity denied to other generations to make a world not only worthy of all of us and of the generations without whom we would not be here, but a world worthy of the children and grandchildren yet to come. There are many ways to be involved in these issues, and I urge you to become involved. I want to make just one last remark. I talked about how exploring those other worlds gives an insight, a perspective, useful for judging our own. And I want to mention to you a set of pictures that has not yet been released that you will see in another month or so, sometime next month probably. When the Voyager 1 spacecraft left the planetary part of the solar system, we were able, turned out it wasn't easy, to get it to turn back and to photograph all the worlds it had left. And so we now have a portrait of the solar system in which we live. There's a background of distant stars. The planets are spread out on either side of the sun. The sun looks wonderfully like a child's drawing of it, with rays coming out because of diffraction produced by an obstacle on the spacecraft. And you look at those planets, and they're very small. Some are lost in the background of brighter, more distant stars. And then you look for the Earth, and you can find it. It's not very bright. It's not very big. It's one pixel, one picture element. It's a blue dot. That's where we live. Our home is a blue dot. I ask you to cherish that blue dot. It's the only home we have. Thank you, and good luck.